Welcome to the Engineering Update. I'm WDD's Editor-in-Chief Janine Mooney, and in this week's episode, reducing in-flight airplane noise, why astronomers want to put a kibosh on the iRobot lawnmower, and an all-girls engineering class.
Of the many dramatic liberties taken by Hollywood, one of the most egregious for me as a frequent flyer is the idea that commercial flights are a tranquil experience.
Surely you can't be serious.
I am serious, and don't call me Shirley.
They're stressful, uncomfortable, and loud. Very, very loud. Most airplanes use lightweight materials with a honeycomb-like structure to line the floor and ceiling of cabins, and while these materials are both strong and energy efficient, they're notoriously bad at blocking low-frequency noise, like, I don't know, an aircraft engine. And traditional insulation materials would add too much weight. That's why this
Republic. No. Ultra cool. What, are you kidding? What is it again?
is actually a lot more like this. But researchers from North Carolina State University and MIT have developed a lightweight membrane that covers the honeycomb structure like a drum and causes sound waves to bounce off. The membrane effectively wards off low-frequency noises below 500 Hz, and a 0.25 millimeter thick rubber material blocks 100 to 1,000 times more sound energy than normal. And the weight increase is minimal. The membrane only adds about 6% to the overall weight of the honeycomb structure.
iRobot, maker of the Roomba, the vacuum cleaning robot, is battling astronomers due to their newly proposed product, the robotic lawnmower. Now let's be clear, iRobot isn't the first to make or attempt to make a robotic lawnmower, but according to a recent FCC filing, they're the first to try using a wireless beacon system as opposed to an edge wire. Although edge wires work, digging up your yard to install them isn't very ideal, so iRobot is taking another approach. They want to replace the edge wire with a series of the small wireless beacons, averaging about 4 to 9 depending on lawn size. You drive them into the ground around the perimeter, and iRobot's robotic lawnmower will use the wireless beacons to calculate its position on your lawn. So why are astronomers kicking and screaming? The beacons operate in the 6,240 to 6,740 megahertz range, which is beyond the range the FCC allows fixed outdoor infrastructures to be. iRobot wants the FCC to approve their request to design and deploy the robotic lawnmower using the wireless beacons, and argues that the beacons aren't fixed, are low power, close to the ground, and aren't going to be running most of the time. The National Radio Astronomy Observatory is not on board. They currently use the 6,650 to 6,675.2 megahertz range to spot the spectral signature of methanol out in space. Methanol shows star-forming activity and is used by the NRAO to measure distances and chart the course of galactic evolution. Naturally, the NRAO is worried that the radio astronomy data will be interfered with. They stated that there could be a complex and disruptive interaction between the iRobot emissions and their signal chain. In response to this, iRobot commented that their proposed operations have a very small likelihood of impacting any radio astronomy measurements in the band. What do you think? Is it really worth potentially compromising our ability to see and track star formations and the galactic evolution? Probably not, but weigh in below.
Women make up only about 14% of engineers, and the lack of female engineers in the field has been a topic of great discussion. Morristown High School in Morristown, New Jersey has been experiencing this problem firsthand. The school offers a number of engineering courses, including a Principles of Engineering class, as part of Project Lead the Way. Mariel Kolker, an experienced teacher and engineer, found the number of girls in her classes dwindling from 6 one year to 2 the next, and finally she taught a class with just 1 girl. Realizing that something was wrong, Kolker decided to try something a little bit different, an all-girls engineering class. To her surprise, 67 girls indicated interest in the class. I recently visited the high school to meet with the girls and their teacher and learn how effective the class has been, and also why the class was necessary in the first place. Kolker said she wanted the class to be a comfortable place for girls to learn, but that they had had discussions about how teaching an all-female class was different from the essentially all-male classes. She realized that while boys like to just jump in and go for it, girls prefer to talk through the challenges and problems before getting started. She also found that while the classes turned equal amounts of boys and girls off engineering, it had a profound influence on girls wanting to pursue engineering as a career. The class introduces students to basic engineering skills and is a combination of hands-on learning like building bridges, supported by math and physics. You can view the full interview with Kolker at www.ecnmag.com or click the link below. That's all for this week's episode. Be sure to check in on Facebook and Twitter and catch past episodes on ecnmag.com. For the ECN channel, I'm Casey Panetta, and this has been your Engineering Update.